In the previous video, I defined polar coordinates, and we computed the gradient operator in polar coordinates. The gradient operator operates on a scalar field. In this video, I want to talk about the divergence and the curl of a vector field in polar coordinates. So our vector field is living in 2 dimensions in the xy plane, and we're using polar coordinates r theta to represent the coordinates of the vector field. But the divergence and the curl then will be taking the derivatives in the xy plane. The curl we'll see actually ends up with a vector that points it in the z direction. So we start with a vector field now, u. So u has an r component. We'll call that u sub r, which is a function of r and theta, and that's in the r hat direction. And it has a theta hat component. We'll call that u sub theta, which is a function of r and theta, and that is in the theta hat direction. Our del operator, the gradient, is r hat d dr plus theta hat 1 over r d d theta. And the other information we're going to need for this calculation is the derivatives of the unit vectors. So we have dr hat depends on theta, so r hat depends on theta, so dr hat d theta equals theta hat. And theta hat also depends on theta, so d theta hat d theta is equal to minus r hat. The only other additional information we'll need when we compute the curl is that the cross product of the unit vectors, r hat cross theta hat, gives us a unit vector in the z direction. So that's k. So we'll need to know that r hat cross theta hat is equal to the unit vector in the z direction. Of course, r hat cross r hat is 0. Theta hat cross theta hat is also 0. OK. So let's start by computing the divergence of u. Del dot u. Let me draw a line here. So we're computing del dot u. We use our gradient in polar coordinates. So r hat d dr plus theta hat 1 over r d d theta, dotted into our u in polar coordinates. So u sub r, r hat, plus u sub theta, theta hat. This is 4 terms, right? And let's write them out. So the first, we'll do the r hat on the left first. So we have an r hat dot, and then ddr operating on this. So ddr u sub r hat, plus the second term, r hat dot, and then ddr acting on this piece here, which is u theta theta hat, plus now the second term here, which is theta hat dot, and then we have a 1 over r d d theta acting on u r hat. And finally, the fourth term here, we have plus theta hat dot, and then we have a 1 over r d d theta acting on u theta theta hat. Okay? 4 terms. Let's see then how each of these terms work out. The unit vectors are independent of r. So the ddr just acts on ur and acts on u theta. But here the unit vectors depend on theta. So we have to be a bit careful when we do the derivatives. So let's look at this first term here. We have r hat dot dur dr r hat. So that just becomes dur dr. If we look at the second term here, we're going to have a r hat dot theta hat. R hat and theta hat are orthogonal unit vectors. So that second term there will be a 0. And now we look at the third term. If we're taking the derivative of ur, then we'll have a theta hat dot r hat, and that will be 0 because they're orthogonal unit vectors. So the only term that contributes here is when we take the derivative of r hat with respect to theta. The derivative of r hat with respect to theta is theta hat. So we have theta hat dot theta hat. And what's left over is a u sub r divided by r. OK? That's the third term. Finally, for the fourth term, we have a d theta hat, d theta. That one is minus r hat. But theta hat dot r hat is 0. So the derivative here acting on the unit vector will give us a 0 term. So we just need to worry about the derivative acting on u theta. Then we have a theta hat dot theta hat. So we end up with a plus 1 over r times d u theta d theta. OK? So we got these two terms that are derivatives with respect to r. We can combine them into one term. This one works out to be 1 over r d dr of r times ur, right? Because the derivative of the first times the second will be ur over r, plus the first times the derivative of the second. The r cancels 1 over r. And then we have a dur dr. So this is a way of combining the first and the third term here. And the remaining term is 1 over r du theta d theta. OK? That's a computation of the divergence. So all we're doing here is we're taking the gradient operator and we're dotting it into our vector field in polar coordinates. That gave us 4 terms. And then we have to carefully do the derivatives, taking into account that the unit vectors are a function of theta. We finally end up with del dot u equals 1 over r ddr of r times ur plus 1 over r du theta d theta. Next up, the curl. So the curl is given by del cross u. And our del operator is r hat d dr plus theta hat 1 over r d d theta. We're taking the cross product then with u, which is u sub r hat plus u sub theta hat. Okay, again, we have 4 terms. So let's go through the terms. The first term from the r hat, so that will be r hat cross, and the derivative on this first term here. So d dr of u r hat. The second term then is r hat again, cross the derivative of the second term. So d dr u theta hat. The third term, now we go to the theta hat piece of the first term. So we have theta hat cross 1 over r. And then the derivative of this first term, d theta of u r hat. And finally, the second and the second term, So again, we have a plus theta hat cross 1 over r d theta acting on u theta theta hat. Okay, so 4 terms. Now we have to figure out what these cross products are. And we always have to pay attention that these unit vectors depend on theta. Okay? That's kind of the key in this calculation. So let's look at the first term. Remember, r hat cross r hat is 0. The vector cross itself is always 0. The r hat doesn't depend on r, so there's no way to convert this r hat into a theta hat, so that this first term then is 0. So that's term 1. Okay, what about term 2? Again, theta hat is independent of r. So this derivative only acts on u theta. So we have plus d u theta dr. And what we have left is I'll just write the unit vectors, r hat cross theta hat. Okay, that's the second term. What about the third term? Now we have to be careful. So the unit vectors depend on theta. But if we differentiate dr hat d theta, we get a theta hat. And theta hat cross theta hat is 0. So this derivative then will only differentiate ur. So we'll have a 1 over r dur d theta. And then we'll have a theta hat cross r hat. OK, that's the third term. Finally, for the fourth term, if this derivative acts on u theta in the product rule, then we have a theta hat cross theta hat, which will be 0. So our only hope for a non-zero term here is when the derivative acts on theta hat. So d theta equals minus r hat. So we get a theta hat cross r hat, which is not 0. So we have a minus r hat. So the derivative is acting on theta hat. So we end up with 1 over r u theta with a minus sign. So minus 1 over r u theta. And then we have a theta hat cross r hat. Okay? So the minus sign came from d theta hat. D theta is minus r hat. OK. 3 non-zero terms. Now we can use r hat cross theta hat as k. So this is a k. Theta hat cross r hat is, so remember, a cross b equals minus b cross a. So this is minus k. And theta hat cross r hat is, again, a minus k. OK, so let's see how we will write that. We have 2 u sub thetas and 1 u sub r. Let's put the u sub thetas together. A minus minus is a plus. So we have a d u sub theta dr plus 1 over r u sub theta. Okay. And then we have this term, which is a u sub r. So we have a minus 1 over r d u sub r d theta. And they're all in the direction of k. OK, this is actually, this is done. But sometimes you see this written in a different way. We can combine these two terms into a 1 over r times d dr of r u theta, right? So the derivative of the first times the second gives us a u theta over r, plus the first times the derivative of the second, r over r is 1, gives us a du theta dr. So that's another common way of writing that. Minus 1 over r dur d theta. And all of that is in the k direction. OK, that was the curl. You can imagine that if you do this then in a three-dimensional problem, in cylindrical coordinates or in spherical coordinates, it will be very messy. And even the final result is quite messy. But sometimes you need it if you're solving numerical problems in 3 dimensions with some cylindrical symmetry or some spherical symmetry. OK, so that's the curl. We computed del cross u by taking the gradient operator cross the vector in polar coordinates. We have to take care that we differentiate the unit vectors. And we have to use the fact that r hat cross theta hat is equal to k, the unit vector in the z direction. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.